All right, everyone. I'm here with Ziad Asghar. Ziad is Vice President of Product Management for Snapdragon Technologies and Roadmap at Qualcomm. Ziad, it's great to see you again, and welcome to the TWiML AI podcast.
Thank you for having me, Sam.
Hey, I'm looking forward to digging into our chat. We are going to cover a lot of ground. We'll be talking about AI in the cloud, on edge devices and cars, and more. But before we dig in, I would love to have you introduce yourself to our audience and share a little bit about your background and how you came to the field of AI.
Thank you. It's been really exciting. I have this great job where I get to work on fancy new technology that really changes the way people use their devices. And it's been quite interesting because I started with Texas Instruments when they used to be kind of the lead on smartphone and the very early beginnings of what you can call an operating system and how things have changed. So, being fortunate enough to kind of see that whole smartphone evolution that has happened right in front of our eyes. And then really the advantage that I've been able to do at Qualcomm is to take some of these technologies and then to bring it into even additional fields beyond the smartphone. And what's been really amazing is that AI is this new technology that is really spanning across multiple product lines, across multiple technologies, and it's really bringing so many new capabilities that we at least are super excited. Our customers are very excited. Just the value that we are able to bring based on that is superb. So very excited about what AI is going to enable us to do.
Awesome. And I think our listeners are familiar with Qualcomm, but I'd love to have you maybe spend a few minutes just contextualizing the company's role in the AI ecosystem. And we hear about this Snapdragon thing all the time. What exactly is Snapdragon?
Sure. So Snapdragon is the name of our platform that takes the best in class technologies that we work on from camera, graphics, processors, modem, and put it all together into these products that we call Snapdragon product line. And essentially, it has best in class capabilities across all of those vectors. And at the same time, we are leading this wave on 5G right now. And really, I always say this, but 5G and AI are technologies that are very symbiotic. They go together hand in hand. 5G makes AI better, AI makes 5G better. So, really, a very key focus area for us right now are those two technologies, and they come together in the form of a Snapdragon product. We, of course, make the hardware, the software, all the experiences that go around it to be able to create these end products that are just amazing and enthrall our consumers that use them.
Can you elaborate a bit on the symbiosis between 5G and AI? I think my sense is that the carriers in some cases have kind of jumped the gun and labeled their 4G plus technologies as 5G and have kind of disillusioned a lot of us over 5G. I don't know if that's a broadly held take, but how does 5G and AI complement one another?
Yeah, I think that's a great question. But you remember this is pretty much the same thing that we saw with the advent of 4G. There was a lot of terminology thrown, and it meant very different things. And did it really mean 4G or not? So there is some of that going on. But I think the way you should think about 5G is millimeter wave brings in the amazing capabilities of unbelievable throughput, unbelievably low latency, and that is what really changes the game. I think that's superb. And the way AI and 5G come together is just think about it this way. We are applying AI techniques to how our modems work. Modems are the basically the blocks that allow you to receive the signal from the air. And by applying AI techniques, we're actually able to make them work more efficiently, to be able to glean the signal from most complex of channel conditions. And that's how AI makes 5G better. But the way 5G makes AI better now is that basically with the advent of 5G, we have intelligence that's interspersed across different parts of the network, right? We have it on our mobile phones, we have it in our connected cameras, we have it in our devices of all sorts. But what 5G does is that it now bridges the gap between the end nodes, which might be these end products, all the way to the cloud. And in doing so, what it allows you to do is, even though the right place to do AI is on the device for privacy, for immediacy reasons, but now with the leverage of 5G, if there is need for accessing more AI capability, you can basically extend your intelligence into the cloud, do more work over there, and be able to bring it back to the device very, very fast. So this is what we're calling kind of the advent of a distributed intelligence across the whole network, and that's what is possible due to 5G.
Okay.
Yeah.
Well, let's maybe start with the or continue with the device and dig into what's new in enabling developers to take full advantage of AI on mobile devices.
Sure. I mean, today many people might not realize it, but there are many use cases that are already using AI on the device. So, for example, the imaging experience has been completely changed, transformed because of the application of AI, right? For example, now your cameras on your devices can see into the darkest of rooms. It
Yeah.
allows you to be able to do, right? I mean, sometimes my eyes can't see, and I take a picture and my phone can see through it. But that's the power of AI, right? We are basically training those models to be able to take out the image or the picture from the darkness. Very, very powerful.
It's
But
been
what
an
is
incredible revolution in just how much of photography has shifted from kind of these physical characteristics like the lenses to software, and AI has been a big part of that.
Absolutely, right? The fact that you can do face based payments, it's driven by AI because of the fact that now you can use AI to basically check for liveness. Because if somebody tries to trick that image by putting a picture in front of you, AI can
Mhm,
actually tell you if that's a person in real life or not, right?
mhm.
But the power of AI really is not just on imaging. We have applied it to audio, we've applied it to speech. I mean, in the past, we were able to use this to be able to do machine language translation, right? And to be able to do that on the device is a very different experience than to do it in the server or the cloud. Because now what you can do is you can actually have two people that live, in far-flung places, can talk to each other, but your devices are going to make it almost seamless for you to be able to converse together with each other. Very, very powerful. And then what we have done is we have applied that to echo and noise cancellation. We have applied that to imaging. We've applied that to video now more recently, where you can literally take a video and take out the object or the subject of that video and replace it with a different person. Now, that is, of course, room for a lot of fun exercises that you might see on social networking as well, where people are saying things or doing things that they're not really doing. And that's why there's also a security element that comes through. And we talked about that also, which is content authenticity initiative that we have basically engaged with to make sure that what you are seeing is truly what the camera was able to capture. But
Mhm.
what makes this work on the device is basically best in class hardware. And what I mean by that is not just peak performance, you got to be able to do that AI processing at the lowest power possible. For it to be able to work in these handheld devices, it has to be able to do it at very low power. Then we need to have pristine software that's able to work at many different levels of the stack. So we offer what we call Snapdragon Neural Processing SDK at a higher level. We offer something that we call Hexagon AI Direct at a lower level to be able to write very close to metal to get the most out of the hardware. And then the last piece is really tools and methodology or algorithms that make it possible for people to be able to use AI more efficiently. What I mean by that is, so we've introduced what we call AI Model Efficiency Toolkit, and we've open sourced a lot of this. But what we do is we work with our corporate R&D team. They develop certain methodologies to quantize the networks, to be able to compress the networks. And by the way, those techniques are providing so much uplift to the amount of AI processing that we can do for a given amount of power that we are able to get a lot out of it. So, like for example, if you quantize a 32-bit floating point model and take it to 8-bit integer, you get 4x improvement. We have shown that by compressing and taking out the redundant parts of a network, we get 3x compression. So many a times you can reduce the consumption by 3 times, and that we do by applying single value decomposition or Bayesian approaches to be able to do that. We have talked about add around in our recent paper, which is adaptive rounding. So, if you round to the nearest number, the accuracy is different than if you are able to do adaptive rounding. So, those are the kind of technologies and techniques that we are spending a lot of time and effort on to really be able to make it work across different domains to be able to do more processing at the lowest power as well.
Where do these tools fit in the kind of the tool chain of the mobile developer? Are they typically using the Snapdragon tools directly, or are they accessing them via their OS, iOS, Android, whatever the device is? And there are kind of OS layers that take advantage of the Snapdragon tools.
Yeah, that's a good question. So the way it's done right now is these techniques are open source. So technically anybody can apply and use them, but they are fitting, of course, very closely into the Snapdragon neural processing SDK, because that's where we're able to get a lot of the benefit out of it. It's done specific to our hardware such that we can get all that benefit out. But yeah, there isn't anything that prevents those techniques to be used by others as well.
Hmm. Hmm. And so, digging a little bit deeper, um, the Snapdragon architecture at the hardware level,
Mhm.
is constantly evolving. And as a Android user and a phone connoisseur, I'm always kind of waiting for the latest and greatest. And this time around, this year, it's the 888. Is that right?
That's right.
What does that do for me as a AI user?
Sure. So let me spend a little time talking about the hardware. So we are continually updating hardware to get the most out of what we are able to do on the smartphone device. But what we've specifically done on Snapdragon 888 is we typically take a heterogeneous approach. So our AI engine is a combination of what you can do on the CPU, what you can do in the graphics, and then what we call our hexagon processor. And what we're able to do with the Snapdragon 888 is a combined peak performance of almost 26 trillion operations per second. Well, that's a heck of a lot for a device that fits in the palm of your hand and can really run the whole day. So what we have done specifically on 888 is we typically in the hexagon processor have three different components. We basically have the scalar part, the vector part, and then the tensor component. And if you look at a typical model, a neural model, neural network, Sam, what you would notice is that there is an initial part which basically maps very well to the scalar component. And then there is typically an end portion, which is like the fully connected layer, which kind of maps very well to the vector part. And then many of the intermediate layers map very, very well to the tensor processor. So that's how we're able to basically put all of them together. Now, in the past, some of these sub blocks, they were not all together into a fused architecture. With the 888, we actually brought them together in one architecture. We have wrapped around a much larger shared memory, and by doing that, we are actually able to reduce power a lot. So I'll give you an example. One of the problems in AI is that people need to move a lot of data, which is the weights and activations from where they're stored into the AI block where they're processed. Now, if you have a larger shared memory, which in this case, it's many times more than what we basically had on the previous generation part, you're able to bring a lot of power consumption savings. So we are able to bring in almost 2 to 3x power consumption saving in some scenarios by doing that. At the same time, as you context switch between those different subblocks, the vector or the tensor component, you're actually able to reduce the latency significantly, in some cases 1000x more. So really improve the efficiency all around from a power, from a peak performance, from a latency perspective with this new architecture that we have come out with. We pretty much do like a major upgrade of AI architecture every other year with minor upgrades in the middle as well. Just because this field is evolving so fast, we study the different networks from the perspective of what we're seeing our consumers and our customers do with the device. And based on that, we're continually upgrading different components to make it run even more efficiently than before.
Mhm. And do these advances kind of come from the traditional just our ability to squeeze more transistors onto a given device size, or are you pulling in innovations from the all the research labs that you're doing, papers, things like that? What's the kind of balance of um, just the evolution of the product versus incorporating research concepts?
Yeah, definitely it's coming a lot from the research that our corporate R&D team does. I mean, just to give you perspective, we have more than a decade of research before we actually brought AI to a product. And our first product that actually enabled this was in 2015. So we're really continually changing the architecture because you can get a lot out of that today. I mean, what has made AI work on the devices is the fact that you can do so much processing on the device at low power, which you could not do in the past. And there is still, by the way, a lot more that we can take out with the combination of, like I said, hardware, software, and the tools. So definitely, we are also continually looking at new approaches. There are other methodologies and architectures that people are studying. We keep an eye on those too, but of course, we're very close to the product, so we want to make sure these are techniques that we can commercialize. So there are other things that our teams are looking at more from a pure R&D perspective that you will see coming to the front in future years.
Okay. So we've talked about in the setup to this, we talked about 5G enabling this kind of distributed environment between the mobile devices and the cloud. Let's maybe jump over to that cloud side of things. I had the opportunity to attend the Cloud AI 100 launch a couple of years ago. This is a new infrastructure hardware that Qualcomm's been working on. What's new on that front?
Yeah, I think it's actually a very exciting area. So, these advantages, Sam, that I talked about from the perspective of mobile, by the way, they are as important also on the cloud side. And the reason for that is, I mean, if you look at, big data center or big platforms like, let's say, Facebook, you will notice that they have publicly said that they have inferences that are happening in the range of about 200 to 400 trillion inferences per day. That's a pretty massive number. And then
Mhm.
that growth trajectory is very steep. So some of the data that people are looking at is the data center power is doubling every year. So unless and until people are able to change the architectures used in the data center, you really start to push against a wall. So what the Cloud AI 100 does is that it basically takes that advantage that we've created on the mobile side and really, of course, in a very different setup, leverages all of our advantages, all of Qualcomm's pedigree for best in class performance for the least power, and then brings it to the cloud. And we're really seeing applications on the cloud side. We're also seeing applications in what we call like smart city like applications. So you can envision, right, that you have, let's say, multiple cameras installed at a junction, and then of course you can't have as many people staring at each of those streams. So that data is actually going into a device like the Cloud AI 100, where we are able to make sense of what that video stream means. And if an event has happened, an event like an accident perhaps at the intersection, or something else, right? So those are kind of the scenarios that we're talking about. And we recently actually published data for ML Commons, and it actually shows that Cloud AI 100 really leads for 50 watt and for even smaller configurations of power for the amount of performance we are able to get out of that platform. So very exciting, really, to be able to move into this new area. We have multiple partners that we're working with right now.
And ML Commons is a benchmarking effort.
That's right. So it's ML Commons is basically kind of the umbrella org, I believe, for ML Perf, and they published a lot of results very recently for the cloud side of things, and very very good story for us. I mean, if you look at something like ResNet 50, if you look at other networks, you'll see the power of the Cloud AI 100 like product that shows very well on ML Commons.
And is with Cloud AI 100, is it taking that core Snapdragon architecture or the architecture that underlies the Snapdragon and scaling it up to kind of the scale of a card that might go in a server in the cloud for inference, or is it a different architecture?
Yeah, I think the way we develop that IP is that we have a root IP where we leave a lot of configurability is the way to think about it, right? So, for example, the TCM or the memory that you have in the block can be modified. The amount of processing that you have in the tensor core can be modified, or in the vector section can be modified, or the precisions that you are making available in those cores can be modified. The process node comes into play also here and there. So my point is there is a lot of configurable, the number of cores that you might have, right? So the root IP you can say is probably very similar, but as you make all those changes, it leads to a very different product, but it still has those fundamental benefits that we brought in at that research level. And that's why we think Cloud AI 100 really shines in terms of the performance that you're able to see. So yeah, leveraging all the benefits, but definitely a very different machine than what we have in the mobile side.
Mm-hmm. And I mentioned this, but I want to make sure that I'm correct. The focus for the Cloud AI 100 is primarily, or maybe even exclusively, inference as opposed to training and inference. Is that correct?
That is right. So it's primarily focused on inferences. It's a machine that's built ground up with the right architecture for inferencing rather than leveraging a CPU or GPU like architecture, because that makes a fundamental difference in the power consumption that you can get.
Mm-hmm. Mhm. And you mentioned that this is primarily targeting these large platforms like Facebook. This isn't a GPU that you're going to just go and install, get one on Amazon and install it in your server. Am I correct about that?
You're absolutely right. I think what people are realizing that as the inference need is really going up and ramping up, people are realizing that the CPU or GPU architecture cannot scale. It cannot scale to be able to give you the level of inferencing needed at a given amount of power. And I think that's where the advantage really comes through for the architecture that we have within the Cloud AI 100. Very, very strong story for us. And I think what we have also been able to do, as we'll kind of talk about, I think, is take some of these processors like the Cloud AI 100 and take it also into other areas. For example, on the Ride platform that we have launched, which is for automotive. So it's giving us a lot of flexibility in being able to take that wherever there is a need for massive inferences at low power, this becomes the platform that we are able to use.
Mhm. And is it available? Are there partners in the ecosystem that offer it kind of as a service underlying a cloud service that is accessible to developers?
Yeah, so it is available today. We already have partners that we are working with to launch on multiple different product segments. And yeah, we'll be talking about some fairly soon here, but we did announce one very recently. So this is an engagement that we had done when Gigabyte. And what it does is it actually takes not just one, but multiple Cloud AI 100s into a server rack. And by the way, we stopped talking about tops in that configuration. We talk about pops, as in peta ops
Peta
of
op?
performance. Yeah.
Wow.
so, so yeah, very, very strong platform which you can scale very well. Yeah.
Awesome. You mentioned the Ride platform. The company's been active in the automotive segment for a while. Can you give us a summary of that Ride platform and what you're up to in automotive?
Sure, sure. I think again, from an AI perspective, it's really an amazing area what we're seeing with automotive. I think it's starting with, of course, just looking at the very low level at inside the cockpit, so driver monitoring at a very very low level, and then going into L1, L2 like autonomy, and then it scales all the way into L4, L5. And what we're able to
Mhm.
do is the right platform is that we have that ability to be able to scale from say about 50 tops then to 400 tops and all the way to like 700 or 800 tops of capability that allows you that scaling, that continuum of performance, and then you have algorithms that you are able to scale. I think auto of course has very special needs and poses very special challenges as you move into electric vehicles. I think power consumption is absolutely pristine over there as well. The kinds of models and networks are more perhaps focused on, of course, object detection. But now you have very different kinds of sensors. You have LiDARs, you have radars, you have multiple cameras, you have very high bits. So it's not about image quality, but it's more about gleaning information from that. So I think in that context as well, the architecture that I explained, which is this heterogeneous like approach, actually works extremely well. We're seeing very good traction with multiple customers. And as you know, the way we've done this is that we started our work on the automotive side with infotainment. And then we've taken a step towards, very simple ADAS. And then, of course, we're continuing to build on that as we move into autonomy. So we feel we have all the building pieces. We think we have very good engagement with partners today that give us a very good path to grow on that side also.
Yeah, that was going to be my next question. You've clearly have the research capability on the pure AI side. Are you primarily going after this market with partners to develop the vehicle specific capabilities, or are you investing in kind of domain specific research that's relevant to these auto and autonomy challenges?
Yeah, I think it's a mix of both, really, because we need to do some fundamental research to be able to make sure we're creating the right hardware, software, or tools, but now also developing some key algorithms that are able to make sure and make use of that hardware. So we build those building blocks, and then of course on top of that, we work with partners who are doing a lot of research, who have a lot of data based on their current experience, and then we can build on top of that platform that we have built. But the strength that we are able to bring to this is we have that very large investment already done on the mobile side in many cases. And it's very easy for us to leverage this into these new areas that we are growing in all the different domains, from hardware, software, but also from an algorithms perspective, from tools perspective, that I think gives us a leg up that other people don't have in this space.
Mhm. You mentioned this kind of path from, I forget the low end of that, maybe 25 tops. And again, we're
15
talking about tera
software.
operations per second, up to, into the hundreds. And you also mentioned kind of infotainment to driver monitoring to level 1 to level N autonomy. Like, are those to what are those correlated? And how are those correlated? And what's the tail that's wagging the dog here? Are the compute requirements in the vehicle a limitation, or is the limitation for the higher levels of autonomy, is that currently on the algorithmic side or integration? How do you just see the challenges that are taking place in the vehicle platforms today?
Yeah, indeed. I think it's the need for more peak performance, but it's also the need for specific kinds of algorithms, and then a porting of those algorithms to the hardware that you are able to run at the highest performance level. And I think there are challenges in each of those steps. So you need to be able to optimize models very quickly. Again, tools come into play over there. You need to be able to get to that peak performance and be able to sustain it, right? Automotive is a very sustained use case. It's not a use case where you go up for a little bit and you got to come down. And then of course you have to have redundancy. You need to have basically a surety, and you need to have multiple different layers of redundancy built into it. So yes, it's algorithms that have to improve with time, but it is also the enablement, which is what I mean by that, is hardware, software, and then of course the tools and everything that come along with it. But I think automotive is very exciting too, because the problems that we are solving in automotive, I think we'll find its use in many other places. For example, what I mean by that is we're working a lot on robotics. We're working a lot on autonomous. For example, not just cars but drones and other things. We demonstrated this some time ago, and I think it's really quite powerful that you can then learn and leverage those things into these adjacent and new areas that will come with time as well.
Yeah, let's dig into that a little bit more. I didn't realize this, but I think you had a role in the Mars chopper.
Yeah, we're quite excited about that actually. Yes, so the Ingenuity chopper that you have on Mars, I mean, this is an engagement with Qualcomm and NASA. It's really amazing to have a product that I worked on actually quite some time ago, that now sits on another planet. And actually, it's just amazing to see that. And actually, it's using the navigation. It's using a virtual, rather visual inertial odometry. It's using object detection. Many of the capabilities that we have baked into these products that are
Mm.
being used on that chopper. It's really surreal to some extent to be able to see, human presence, and for the first time, something that is like a chopper on a different planet. So we're very excited with this engagement, and to see many of the tools that we developed being used actually in this experience. And you can see and you can envision that as we do a lot more on autonomous, for example, route mapping and things of that sort, you can do a lot more of this stuff in these kind of environments where you don't have direct human interaction to some extent. It's just amazing. I mean, you can envision, very tough environments, even on Earth, where you can leverage a lot of those experiences and learnings that we have gotten from there. So, very exciting. I mean, we were watching it when it was landing on Mars, and we've been tracking pretty much closely ever since.
This is maybe a silly question, but I'm thinking about like 5G on Mars. Is this a connected application, or is this a autonomous application, or a hybrid?
I believe there is some link to the mother rover that they have over there, but
Mhm.
to a great extent, it can be controlled separately as well. But it would, of course, be other more shorter term technologies that we would be using to have the
Sure.
two basically talk to each other. Otherwise, I'm all for those base stations on Mars. So
And so, we've talked about cars, we've talked about choppers. These are examples of kind of this broader IoT and devices landscape that enterprises are increasingly interested in. You mentioned smart cities earlier. Um, are these, to what degree are you specializing to enable these various applications, or is the kind of the core capability, are the developers kind of getting you there to the specific applications?
Yeah,
Sounds like you're doing a
definitely.
little bit of specialization in automotive, and I'm curious if that
Yeah.
is a pattern that extends across to other areas in IoT.
Yeah, I think IoT and some other fields have usually a very varied sort of application, right? So you'll find many different applications. So in that case, our plan usually is to enable some of these things, and then our partners, whether those are ISVs or customers, they're able to take it from there, customize it to their specific needs. For example, very recently at the China Tech Day that we just had, I think a couple of weeks ago, we actually showed an application of the robotics platform where you actually have a robot playing ping pong, and that actually uses the AI technology that we have developed to actually train the players to be able to play very good table tennis. Right? Of course, this is one
Mhm.
example of it, but there is a lot more that's happening on the IoT side in also what we call big IoT. So, one example that you can think of is like smart retail. Now here is the case where basically you would have multiple cameras again with people coming into a store like a completely autonomous store. They buy certain things and you're automatically checked out as you walk out of it. You of course have multiple cameras that are tracking the devices or the products that you're buying. It's able to object detect, it's able to figure out the cost of that one. It's automatically able to check you out. So it's quite interesting what we'd be able to do on many of these applications, but these are still of course developing. But there are simpler cases of this that can be done today. Like in the self checkout line, there might be concerns of say pilferage or of errors in people basically buying certain goods, and are already plans like this where you have some intelligence on the camera versus some intelligence in the cloud. You're actually able to cover it quite well.
Mhm. When you refer to big IoT, is the distinction you're making there kind of multiple devices needing to collaborate, and kind of this distributed AI
Mhm.
use case? Or, yeah, and if so, what are some other examples of where you've really seen us kind of push that?
Yeah.
I know that I say that kind of knowing that the at the research level, you're doing a lot on federated learning, and that's an
Mhm.
evolving field. And I'm really curious, like, how far are we in deploying solutions based on that kind of research?
Yeah, that's a good question. So already when I say big IoT, I mean multiple devices, kind of the way you explained it, and then different levels of intelligence within those devices. So maybe you can do a course AI assessment, and then based on that outcome, you're able to pass on to a central, more capable AI that now does the finer level of assessment, right? So that's kind of an example of big IoT. But at the same time, I think the experience has changed a lot. Like I always give this example that I have this security camera outside, and every time a person passes by, it basically pings me. It's really quite wasteful, right? I mean, if we have a little bit more intelligence there, you would have the ability to be able to ascertain if that's a car, if that's a person, and if that's a person, is that the person that is a safe person or not, right? So it has applications of what I call big IoT, but also as we pack in more AI into connected cameras and other devices, you'll see a lot more over there. And I think then the kind of the second part of your question, sorry, second part of your question was on the
Just
research,
the
federated learning. Yes.
federated learning and the degree to which that is starting to see use in industry.
Yeah. So I think, by the way, federated learning is something that's already happening on the devices. So if you take the example of the Google keyboard, what you're able to do there is that it actually takes some learnings from the way you use the keyboard, and then actually it's able to apply that into in the cloud, where basically it aggregates a lot of those needs to get to the best in class experience. So the other people who then download the Google keyboard are actually able to leverage and take advantage of that learning. So that continues to get better over time. We're also doing research on some limited training on the device. I think it can actually open up some very interesting use cases. Like another set of use cases we haven't talked about is like always on AI. We're doing this on many devices, and the idea would be there is a large engine that can do very complex AI, But there is also a very small engine that we have introduced in our products that uses less than a milliampere of current, and it's always on, which means it can listen, it can take in multiple streams coming into a product, for example, location stream, other streams, to create a contextual picture of where the user is, and based on that, take certain actions. So really, the options are very wide in what we are able to do in always on versus active like scenarios as well.
And is the idea there the next evolution of the wake word, like Alexa or Siri?
Absolutely, but a lot more than that. See, that
Hmm.
is just taking the microphone input. But now
Yeah.
envision that you can also take in the camera stream. You can take in the location stream. You can take
Hmm.
in, video stream.
Accelerometer. Hmm.
Exactly. And all the sensors that you have, e-compass, gyro, and all, you aggregate all of that, and you can now do some very interesting things already on the device.
Hmm. Hmm. And have you seen any specific applications of that
Yeah.
jump out at you?
Yeah, so like there are some very good health and security applications that already come to mind, right? If you are able to assess with certain degree of accuracy, for example, that you are the driver of the car, there are certain functions that automatically should not be available, for example.
Hmm.
Or let's say if you know that based on the timeline that there is a loud noise in the middle of the night, for example, you know that there is an event that has happened that probably needs to be catered to, right? So there are some very interesting
Hmm.
ideas like that are coming up. I mean, for example, if your phone is able to determine that you're in a very noisy environment, it can automatically increase the volume of your ringer, for example. Right? Many convenience factors, but also health and security aspects there.
Hmm. Yeah, we've talked about yeah, use cases like retail and smart cities, and yeah, even the always on AI application brings the question to mind. Yeah, there's a growing concern about surveillance and kind of pervasive cameras and things like that. And I'm curious what the Qualcomm take is on that.
Sure. I think definitely privacy comes first, right? We need to ensure that our private data stays private. And what we are able to do in that regard is we have a very strong security component that we build into each and every one of our products, Snapdragon products. And that is meant to make sure that the data that is supposed to stay on the device stays on the device. And that's why I mentioned, I think there is a very good benefit of having more AI capability on the device because now
Mm-hmm.
we can do all of that processing on the device. The data doesn't need to go anywhere. And you're able to actually make sense of it, especially data that has, like, let's say, your face information or anything that's very, very important from a value perspective should stay on the device in that sense.
Mm-hmm. Hmm. So we've talked about a bunch of different areas, and what's available today, and where things are going. Near term. What are you most excited about? Kind of looking into the future and the different applications you're seeing arising.
Sure. I think the part that I really get excited about, especially from an AI and its applications, is I think what I call AI for good. I think there's a lot of potential there. So there's one initiative that we had done with Tata in India, where basically you could take a smartphone and put a small lens behind that, and then you could basically point it at the eye of a person, and you'd be able to glean information from their retina. And then you can
Mm.
actually run an algorithm where there might be a location where there isn't a doctor close by, and it does a very coarse but a good assessment of if there is any concern on, let's say, conditions like diabetic retinopathy, right? If any such condition is coming in, it can automatically warn, it can tell you to go see a doctor. I think there are many applications like that where as we start to get more AI processing on the device which is able to monitor our health, I think there's a lot that we can do there. Make sense of it just from the amount of information that's already there. If you have a smartwatch, you have your heart rate, but to be able to make sense of that in combination with all the other factors that you have. Because, for example, if you have a smartphone and a smartwatch, now you can ascertain very well if the person was standing and he's no longer standing, for example, right? There is a lot of such what I call AI for good. And I'm quite excited that it will make life better. It will make the people's life safer, right? For example, cars. As you do more of this autonomy, I think autonomous cars will turn out to be a lot more safer than human drivers. And
Mhm.
if they can save lives, if they can make the experience, safer for especially teenagers, people who are just learning how to drive, I think that those are all,
Yeah.
great things that I think if you're a technologist and if you can get something like this, it's very heartening and it makes you feel good that your technology is going in a place which makes humans' lives better.
Awesome. Awesome. Well, Ziad, thanks so much for joining us and sharing a little bit about what you and Qualcomm are up to.
Thank you for having me. Enjoyed the discussion very much.
Same here. Thank you.
Thank you.